Hi, I'm Ashwin from Marvell. We are here at OFC to show a live end-to-end AI data center demo built on Marvell Teralynx 10th scale-out fabric, validated with Keysight's AresONE M800 gig and AI data center builder.
Hey, this is Avik, product manager from Keysight. As the AI fabrics are getting more and more complex, it's becoming important to tune the fabric performance for optimum network utilization and identify the bottlenecks created in the transport layer.
Together, we are answering three practical questions AI operators keep asking. What's the job completion time can I expect on a Teralynx fabric? How does it handle packet loss and GPU underutilization? And can the same fabric support both Rocky V2 and emerging Ultra Ethernet transport payloads? So the setup we are looking at here is actually a fully non-blocking Teralynx-based co-fabric with leaf and spine switches forming end-to-end 800 gig topology. We've enabled Teralynx auto load balancing so we can compare classic ACMP, flowless, and packet spraying under real AI collective patterns.
Yeah. And on the workload side, Keysight's data center builder is emulating realistic AI workloads over a fully stateful transport into this network. So we are emulating different collectives, controlling the data sizes, payload size, collective types, queue pairs per flow, number of ranks, and a fully stateful Rocky V2 transport into this. Keysight is also emulating Ultra Ethernet traffic for ordered and unordered delivery type. That lets us stress the network the way real training and inference jobs would do, and also measure the true application relevant behavior.
Thank you. So we are testing two key capabilities. First, how Teralynx auto load balancing, flowless versus packet spraying, impacts the bus bandwidth or the goodput and out of order behavior for all reduced workloads and all-to-all AI workloads at 800 gigs. Second, how Teralynx packet trimming helps manage lost packets and improve retransmission efficiency for Rocky V2 and UET traffic. In the packet trimming test, you'll see that the lossy traffic gets queued up and dropped under congestion, now trimmed and remarked with a dedicated ZSCP and gets forwarded on a different higher priority queue so the receiver can detect loss and trigger fast retransmission.
Yeah, it's extremely important. And our instruments then recognize those remarked trimmed packets, expose the counts for those trimmable and trimmed frames, and correlate them with the Rocky V2 and the UET flow statistics. So you can see in the counters and the views that the packets originally headed for being dropped instead preserved in the trimmed form on another class. And we still maintain the full visibility into how the flows were affected.
So we'll finally tell you why this is important for AI networks. At AI scale, every bit of congestion and every retransmission matters. If you drop blindly, you pay in tail latency and wasted GPU cycles. Our approach shows how Teralynx platforms can balance traffic intelligently and help recover lost packets without sacrificing throughput and GPU cycles.
Yeah, and this is exactly the type of visibility the AI operators need. You can drive the fabric at high-speed line rate across multiple ports, emulate real collectives, and still pinpoint where the congestion occurred, which packets were trimmed rather than dropped, how retransmission behaved. That shortens your tuning loop and de-risks scaling to the larger clusters.
Finally, we'll talk about the differentiator here. What's unique here is that we are demonstrating how our flexible and fully programmable hardware pipeline enables Teralynx to act as a unified fabric for GPU clusters with and without the UEC compliant NICs by enabling complementary features like auto load balancing and packet trimming.
Yeah, and it is actually pretty cool because this setup doesn't only provide the high-level network utilization, but also lets you drill down into the underlying stateful network behavior that impacts it. A suboptimal network performance can be a result of network not handling the transport very well. And this whole solution lets you drill down even at a queue pair level and identify the choke points created by this retransmission or packet reordering, etc. And then finally correlate back to the network performance.
Yep. Thanks for the collaboration. This has been an excellent work, and this would lay the foundation for all the future AI infra deployments that we'll do with Teralynx.
Thank you.
Thank you.